So let's do a couple of examples of how you would write a piecewise function if you're given a graph. So I'm going to do number 36 here. So in order to write a piecewise function, I know that the function is going to be equal to something. So I'll write a little bar like that. And then I'm going to start by just looking at the domain. So I'm going to leave the equation spot different, and I've got 3 spots here because I see that I have 3 different equations. This first one, notice, is going to happen between the domain of 0 and 2 because I'm looking at the x value. So 0 and 2, x has to be between that. And notice at 0, it has a bar because it's a closed circle. The next one goes between 2 and 4. And notice at 2, it has the bar, and at 4, it doesn't. And then the next one goes between 4 and 6. So let's think about what the equation looks like at these places. This one is a step function. Between 0 and 2, the y value remains the same. The y value is always at 1. Between 2 and 4, the y value is always at 3. And between 4 and 6, the y value is always at 5. Let's go do one that's a little bit different. Let's do do 39. Get it in place here. So I have a piecewise function. And I have 3 spots. The first piecewise function happens over here at -1 and gets smaller. So x is smaller than or equal to -1. The next one goes between -1 and +1, and they both have open circles. And then the last one is where x is bigger than or equal to 1. So I just have to write the equation for both. So to write an equation, it's helpful to know slope and y-intercept. So I'm going to find the slope on this one. It's going up 1 over 1, up 1 over 1. So I know it's 1x plus, and then I can find the y-intercept by keep going up 1 over 1, and I see it's at 2. The next one also has up 1 over 1, up 1 over 1, so it's 1x plus 3. And the last one has a slope of up 1 over 1, up 1 over 1, so it's 1x plus, but I have to go down to find where it would cross. They're at 1. So that's what my piecewise function would look like.